ready, 2 minutes to go for the start of today's webinar. This webinar will be recorded, and you'll have a chance to receive the recording link and the slides after the event itself. So you have that as an additional resource. If you'll hold on for just another minute and a half, then we'll be ready for the start of today's webinar. Thank you. Welcome everyone to today's webinar, The Future of Automotive Technology, Keeping Your Curriculum Up to Date. We're pleased that you could join us today. Friends, I'd like to tell you that we have participants from 10 states today and 2 countries. Welcome everyone. Let's see, what was my winning state here? Well, Michigan, I guess that's not too surprising. They won the prize for the most participants, followed by Delaware. They came in second, so that's interesting. Now it's my opportunity and my pleasure to introduce you today to our presenters today. Let's start with Bob Feldmeyer. He's the Director of CAAT at Macomb Community College. Bob, welcome today. It's a pleasure to have you here. Say hello to everyone and then go ahead and introduce your co-presenters.
Good day, everyone. CAAT is the acronym for the Center for Advanced Automotive Technology. It's a lot faster and easier to say CAAT than all of those words. Other presenters today will be Doug Furtuck, who is one of the assistant directors here at CAAT, really focuses on energy and automotive programs. Charlie Standridge comes from Grand Valley State University, where he's the Dean of College of Engineering and Computing. He was involved in a seed funding project with us, which you will hear more about later. Shannon Williams is with us from Utica Community Schools, where she's a career and education teacher leader. Shannon and Utica Schools have also done a seed funding project with us. Then the last presenter will be Sherry Doherty, who's the other assistant director who does communications for CAAT, and we'll be going over some of our website and newsletter information. So with that, let me give you a little introduction as to what we'll be doing today. I'm going to talk first a little bit about what CAAT is. We're going to do a little recap of the webinar that was done on April 17th. We're going to talk about the highlights of the CAAT conference that we did back on May 2nd. Then get into fairly detailed technical discussion about industry needs in advanced automotive technology, looking at vehicle electrification, lightweighting, and automated and connected vehicles. Want to talk then about some new seed funding opportunities that we have available, and then kind of where we go from here. So a little bit about our center. We're located at Macomb Community College. We're in a suburb just northeast of Detroit. Our primary partner is Wayne State University. They are one of the co-principal investigators with us on the National Science Foundation grant, which we received in 2010. That was an initial grant for $2.8 million. Our mission is to prepare technicians for the auto industry's more environmentally friendly and safer vehicles, and also to be a regional resource for developing and disseminating automotive technology information. Sort of our priorities are obviously preparing technicians and designers for these advanced technology jobs. And some of the information that we've seen is that about half of the auto industry jobs now are not manufacturing. They are actually in R&D and support functions. And there's an increasing flow of students that we need through the pipeline to be ready for these jobs. So we do a lot of things kind of working on middle school and high school students, getting them interested in going into STEM areas. Then we do collaboration with other educational institutions, Wayne State just being one, but there's a number of other colleges and universities we partner with as well. And then we also do a lot of partnering with industry to make sure that we understand and are meeting their needs. Our strategic plan is providing seed funding where we can create curriculum and then have it available for other people to use. creating seamless 2+2 pathways so people can go from a community college onto a 4-year university. We share educational resources via our website. As I mentioned, do a lot with K through 12 on trying to integrate STEM into our activities, and then creating academic and industry partnerships. And through all this then, preparing students for careers in advanced automotive technology. The partnerships that we have, kind of at the top, is the National Science Foundation. We are one of 42 ATE centers, that's Advanced Technological Education Centers, around the country, where we focus on automotive technology. To the left, we do a lot with a variety of different government agencies. We have lots of different industry partners, from the auto companies to major suppliers. We're involved with a number of different professional organizations, and then of course other academic institutions. The grant that we initially received actually expired at the end of August, and we have gotten a new funding renewal for another 3 years for $2 million, which goes through the end of July of 2017. So what this will enable us to do is to continue the work we've been doing in electrification, but also to expand into lightweighting and automated and connected vehicles. Our next presenter is Doug Pertup.
Thank you, Bob. Good day, everybody. I'm going to start first with the first of a handful of polls that have been interspersed throughout this webinar today. I think, Mike, at this point, you tell us how to do this.
I will. Just click to the next slide, Doug, and everybody will see the polling question.
Okay.
There it is. So, Doug, we want our audience, we want to ask them this question. What is your view of the future for the U.S. auto industry? Is it bright, dim, you're not sure? If you've got something else to say, put it down in that chat box. So use the polling buttons, everyone. You can see it's A, B, C, D, D there. Several people have already put them in. So let's just take a minute and reflect. What do you think the future of the automotive industry is? Doug, let's give them another minute or two. Come on, folks, this isn't a hard question. Just make your input here. Okay, Doug, I'm going to count down from 5, and then we'll take a look at the results of the poll. Here we go. 5, 4, 3, 2, 1. There you go, Doug. We've got mostly A's. That's pretty good.
That is interesting. Okay. Maybe we're having some impact here. All right, let me go ahead here. Just in order to help set the stage, we did have another webinar back in April. This is actually our second in a series. And in that webinar, we focused on, first of all, who we are. We went into somewhat greater detail about what the CAAT is all about. And then we talked about smarter, greener cars and about the history, about where the auto industry is going. And we focused, introduced actually the ideas of design and automation and communications on top of what we had been focusing on, which was propulsion technologies focusing on electrification. And then we talked about how to prepare smarter and develop smarter students through curriculum development and dissemination, professional development, and through providing technical and educational resources. This was a chart that was shown at our initial webinar, and the point here is, yeah, the auto industry went through some very difficult times in 08 and 09, and I'm sure we're pretty much all aware of that. But since then, there's been a pretty strong and steady rebound. Now, the second point here I wanted to make is how many employees there are in the auto industry. It's really still one of the largest industries in the nation, and it's going to be continuing at these very high levels, as you'll see again later. One of the things that we reviewed was a chart that was put together by the state of Michigan's Economic Development Corporation, and where they identified what are the drivers of the auto industry future. And they were looking out 25 years. And they identified these 6 things: demographics and vehicle market, vehicle design, connected and automated vehicles, powertrain and propulsion technologies, material technologies, and manufacturing and supply chain. 4 of those 6 I've circled because they are within the scope of the CAAT. And therefore, very important for the, and so the work of the CAAT is very important for the future of the auto industry, particularly in the state of Michigan, but that would apply to any other state that has manufacturers and developers in the auto industry as well. We also spent quite a bit of time, Sherry Doherty did, introducing and describing the CAAT website, which we've spent a lot of resources and effort and partnering with to get input for this website. So we described that website and what's available in quite a bit of detail back in April. So now that's where we got to this webinar. Now what's happened since that webinar back in April? Well, we had shortly thereafter our CAAT annual conference in May. And I wanted to just cover a few things from that conference. These were the keynote speakers, and the focus of that conference was the future of the automotive industry. And we did have Nigel Francis, who is the Senior Automotive Advisor for the Governor of the state of Michigan, and heads up the Automotive Industry Office of the Michigan Economic Development Council. And he has many years of executive experience in the auto industry and has the ear of top industry and government leaders in the state. Kristen Dichek from the Center for Automotive Research, who's another well-known automotive expert, particularly in the area of labor and economics of the industry, also made a presentation. And we had John McElroy, who, for those of us here in southeastern Michigan, he's a well-known automotive analyst and media figure. And he also made a very futuristic, took a very futuristic look in his talk that was very well received by those that attended the conference. We also had some technical sessions talking about electric vehicle taxonomy or organization and naming. We talked about we introduced lightweighting, and we also talked a little bit about connected vehicles regarding especially the Ann Arbor project. And all of the presentations that were presented are posted on our website. I just wanted to highlight a couple of charts though out of those presentations. This was Kristen's forecast for the sales in the automotive industry, and as you can see, they're expecting them to be strong and steady after rebounding from the lower levels of the late 2000s. So that, of course, is important. But not only are the sales coming back, but the jobs are coming back as well. This shows the U.S. production and then also the U.S. automotive employment. And both of them are expected to continue strong out through at least 2018. We then, I'm not going to go through this again, obviously, but I just wanted to emphasize that we focused at our conference on these 4 drivers, and the presenters and the technical discussions were focused on these 4, like a laser. One other interesting chart that was presented by Nigel Francis is he took those areas and then he identified what specific jobs are there that's required what skills are going to be required in those areas. And then he indicated that there's going to be shortages for those occupations. He put those in bold. And there's going to be an underproduction of really underproduced occupations in red. So I'm not going to go through this again in detail. This will be posted on our website, and you're welcome to go back with it and call us with any questions. But you can see just at a glance at the red items, for example, there's going to be a significant need to develop these new skills for the workplace. Okay, we're ready for our second poll. Mike?
Now that was a good lead to this polling question, everyone. How prepared is the workforce in your area to work with these technologies that we've been talking about, the ones that are required by the auto industry to meet future fuel economy standards? So that's the big question, but it's a pretty simple question. What's your view? Please use the chat box, the polling box. Is your workforce in your area ready, sort of ready, not ready? Or you're really not sure, you don't have any direct information? Let's give them a moment to think about that, Doug, and then see what happens.
Okay.
Maybe I should play some little theme music while they're thinking. No, I won't do that. Okay, here we go, everyone. Put in your answers in using the box up above. Please use the fourth horizontal box at the top of the participant window. Click on your response, A, B, or C. So here we go. 5, 4, 3, 2, 1. Now let me reposition this here. Now we've got a spread of answers. Interesting. Some of us say, well, we're sort of ready. A lot of them, the majority, not ready, and the rest of us not sure. Notice nobody said ready.
Wow. Okay.
That's why we exist.
That's right.
Go ahead.
All right. Thank you, Mike. Okay, I wanted to hear that the next few slides here are some of the highlights that I've selected from the presentations that were made at our annual conference in May. This is and also charts that you might find interesting or useful. This is a chart that we showed because we had gotten a lot of questions about. I hear a lot about hybrids and electric vehicles and plug-ins. Just what are all these vehicles and what are the differences? So we just sort of introduced them on this scale, showing from conventional to hybrid to plug-in hybrid to electric, what the differences are in terms of range and total emissions, which of course the emissions at the tailpipe of an electric vehicle are 0, but you don't have, of course, the range. And then we also offered this chart, which has a little bit more detail to identify what the differences are in terms of what the key component differences are across the top, what kind of a drive system these vehicles have versus the start-stop technology, mild hybrid, medium hybrid, and so forth down the left-hand side. So this is just a snapshot that identifies what the differences are in these different types of hybrids and plug-ins and battery electric vehicles. Then we had, as you saw on the agenda for this conference, we had a design overview of the new 2014 Corvette. And the reason we were able to get an engineer from General Motors to come in and give us this presentation is that this is a vehicle that's brand new and that has a lot of technology in terms of lightweighting of materials in that vehicle. So he gave us a lot of information on that. For example, this is a breakdown of what the structure is like, the body structure and assembly of the new Corvette. And it has an aluminum frame that has a lot of application of structural composites, and the exterior of the vehicle as well is composed of composites. And if you have a chance, any interest at all, I encourage you to go to our website and pull this presentation up, because there's a world of new technology that's being applied today on the Corvette. We also talked about connected and automated vehicles a little bit at our conference. And this is another nomenclature issue here. Connected and automated vehicles use any number of different communication technologies to communicate either with the driver, within the vehicle, with other vehicles, with the infrastructure, or with the cloud, and even with satellites. So we're going to be talking a little bit more about this in the presentation later. But we did introduce this topic at our conference. And then finally, I mentioned John McElroy, sort of one of the local auto gurus here, and he emphasized that big changes are going to continue in the auto industry, that fuel economy improvements are getting much tougher to achieve, and that in order to achieve the fuel economy standards, which I'll cover briefly, mass reduction is going to be necessary. With all the introduction of lightweight materials such as aluminum and carbon fiber, There's going to be issues in the collision repair business, for example. He's encouraged the industry and academia to take a close look at the total energy consumption throughout the life cycle of a vehicle, and not just look at fuel economy. And that total life cycle would include the production of raw materials, the manufacturing, the servicing and repair, and of course then the recycling, reuse, or disposal of vehicles. And this has become, particularly in Europe, and it's going to be happening here as well, important criteria in the design and production of automobiles. And then he offered the idea that car sharing offers a tremendous energy savings opportunity in urban environments. He pointed out that the average personal vehicle sits unused for 22 hours a day. So is this a big opportunity for electric vehicles perhaps? And in fact, Indianapolis is putting in a fleet of electric vehicles for car sharing. And so this was one of his thoughts as to how there's going to be significant changes coming in the next few years in the auto industry. Okay, so with that background and with that summary of our conference this year, let's move on to discussion of the updated industry needs in advanced automotive technology in three areas. Basically the three areas that we focus on here at CAAT: vehicle electrification, vehicle lightweighting, and automated and connected vehicles. This is a chart that the Department of Transportation has been using extensively as they talk about the transportation challenges of the future. And they say the challenges are in three areas. One is safety, another is mobility, and then of course the environment, whether the environment be energy or pollutants. And that's an extremely useful way to think about the future of the industry and the technology. So Mike, let's go to the next poll.
Thanks, Doug. So here's the question. Now, Doug was just talking about the challenges. We'd like to ask your opinion of those three. What do you think is the biggest challenge for automotive transportation? Is it related to the environment or mobility or safety? Or maybe there's another challenge that's not in this list that you would like to put in the chat window. So please use your boxes. I see a number of people are pouring in their answers already, Doug. They're getting the hang of these polls. Which is the biggest challenge? Environment, mobility, safety? Well, we've got some comments in the chat window while people are putting in how urban development will impact energy usage. So that's an important one. And here's a good one. I like this one, the balance between all three. Let me give a countdown here, Doug, and then let's take a look at what people thought about this question. So here we go, 3, 2, 1. So most people think it's the environment, close tie for second between mobility and safety, and just as many people clicking other. So an interesting spectrum of responses there, Doug.
Yeah, okay, good, thank you. Yeah, the idea of urbanization, particularly globally, is going to put a lot of stress on all three of these challenges. Okay, so let's talk about the environment first. The coming fuel economy standards in the U.S. embody that drive to improve the environment. And this is a chart that shows what the fuel economy standards have been historically and what they're going to be out through 2025. And you can see that we've had from the early 80s all the way through 2010, it was basically no change in what the fuel economy standards are. But now we're on ramping up to a combined fleet average, including cars and light trucks, of 54.5 miles per gallon by 2025. And I think we can all appreciate, based on what we get in terms of fuel economy on our personal vehicles, what a challenge this is going to be. Now, WardsAuto, which is one of the industry's magazines here in the U.S., does an annual survey of engineers on fuel economy standards, since the fuel economy standards are going to be and strategies are going to be so important in these coming years. So the question is, what technology is your company focused on to help the industry meet those 54.5 composite fuel economy standards in 2025. And this was a survey of almost 1,000 engineers. And for the first time this year, lightweighting or mass reduction was the most common answer. Multiple answers were permitted here. Engine efficiency has been most important in recent years. And of course, the third important one was vehicle electrification. This is why the lightweighting is taken over from advanced powertrains in terms of how we're going to meet the standards. The fact is, a lot of advanced powertrain features have already been applied. And this is maybe not immediately easy to read, but I thought this was a candidate for Chart of the Year here. It shows 4 different technologies: variable valve timing, advanced transmissions, gasoline direct injection, and turbocharging. And it shows all of the major manufacturers by model year when they're introducing these technologies. And so at a glance, you can see that there's more and more variable valve timing has become almost very widely available across all manufacturers. Advanced transmissions are coming, so is gasoline direct injection, and turbocharging is going to be coming on more and more. So the point here is that these advanced powertrain technologies that all help fuel economy and have been responsible for the latest increases in fuel economy improvement are going to be widely applied in coming years. Now, if you look at vehicle electrification, hybrid vehicle sales have pretty much plateaued, surprisingly, in recent years. Although historically, hybrid sales are more tied to fuel prices than anything else, because they haven't been necessary so far to meet fuel economy standards. On the other hand, plug-in vehicle sales, and this is a chart that I took from the Electric Drive Transportation Association. You can see this jagged curve to the right here is showing the monthly plug-in vehicle sales, and plug-ins include plug-in hybrids as well as electric vehicles. And you can see that those sales are continuing to increase on a monthly basis. One other point I wanted to make about that, and this is again a chart from the EDTA, Electric Drive Transportation Association, is that as these plug-in vehicles hit the road, they accumulate, and they all need to be plugged in somewhere. So the stress and the demand on the infrastructure of the nation for having a capability to charge these vehicles is growing at a pretty fast rate annually here, and will continue to do so. As you can see here, there are now over 8,000 public charging stations in the United States, and that number is going to be increasing tremendously. Okay, so we've talked a little bit about advanced powertrain. We've talked a little bit about electrification. The third area is important for the environment in energy is weight or mass. And this is a chart that shows the blue. Let me make sure I've got this here. The blue shows the adjusted fuel economy, actual fuel economy, which has been tracking pretty closely to what the standards were. And since 1980, look at the increase in horsepower and the increase in the weight of vehicles. They've been both going up, even as the fuel economy has been pretty flat. So there have been improvements in the efficiency and effectiveness of the internal combustion engine over those years, but they've been going towards more power and larger and heavier vehicles. This is another way of looking at the, this is number 2 in the cool chart of the year here. This is showing, and this is actually from Europe, but the same effect happens in the United States. If you look at a given vehicle class over the last, since the 60s and 70s, vehicles have been getting larger. So this is again an explanation for why vehicles have been heavier, getting heavier over recent years. This is a visual display of that same point here. If you look at the Fiat 500 from the 60s, and you look at the Fiat 500 that's being produced today, which we all think is pretty small, it's still substantially bigger than what the Fiat 500 used to be. Okay, so where does the weight in a typical vehicle come from? This is a breakdown of a Land Rover, and you can see here that most of the weight is coming from the body systems, with the chassis systems number 2. So you know, a pound taken out is valuable no matter where you get it from, but you'll find as you talk lightweighting and mass reduction with engineers that most of the time they tend to focus on the body. So how do you so how does mass reduction achieve better fuel economy? For the engineers among us, we know that less energy is required to accelerate the vehicle, you know, F equals ma, and that's certainly the primary reason. But you also, the advantage of less mass is also in less rolling resistance once you do get up to speed and no longer accelerating. And there's this what's called a secondary effect. You can take a pound out of the body. You can also take weight out of the remaining vehicle systems that were on that pie chart. You don't need as big of a powertrain. You can use lighter chassis and brake components, smaller gas tanks, smaller wheels and tires. So these secondary effects are what really allows you to benefit even more from the direct mass reduction you might get from a material substitution. Sort of a rule of thumb in the industry is about for every pound you can take out of, say, a body, you can take another 0.3 of a pound or 30% more out of the remainder of the vehicle. So what are the strategies to take weight out of a body or a body structure? Well, if we start here from the right-hand side, you know, you can certainly reduce the size of the vehicle, which is, as you can see from that body, from that progression of vehicle types, we've been actually getting bigger over recent years. You can reduce performance in terms of the stiffness of the body, or crash performance, or maybe other, you know, sound deadening, things like that. Or you can do a better job of engineering, and we're always looking for engineers and drafting and designers to do that. For example, what's called the 3G approach. Can you reduce gauge, reduce the grade of materials, change the geometry, change joint designs, and so forth, still get the same performance, but that get overall mass reduction. And then finally, you have the alternative of converting materials. And usually, this is going to be at a premium cost, but not always. And this is an example of that. If you look at this chart, you can see that certain material substitutions might be able to be done for a cost reduction, but most of them for substitutions like high strength steel, aluminum and magnesium, and continuous fiber reinforced plastics like carbon fiber, there's going to be a significant cost premium. Now, some of these lightweight material applications have become pretty much standard over recent years. For example, most engines today are aluminum castings, both in blocks and heads. Transmission cases are mostly aluminum. Pretty much all the heat exchangers in a vehicle are aluminum. There's more and more use of advanced high-strength steels in certain body structure components. And then a lot of body panels are now becoming aluminum. It's not unusual at all. It's becoming sort of standard or a sustained application of aluminum, particularly in hoods. So if you look at an example of a new vehicle, this is the Cadillac ATS, which came out last year, a little over a year ago, I think. This is showing what the breakdown is in the body structure of all the different materials, and you can see that there's a lot of use of high-strength, low-alloy steels, even advanced with ultra-high-strength steels, press-hardened steel, aluminum. So it's getting to be a very sophisticated design and application of these different materials in the body. This is Toyota's view of lightweighting technologies. And this show, and they've got their kind of they've got their cost reduction potential included here as you progress from sort of an all-mild steel vehicle into one that applies high-strength steels and then more aluminum, and then CFRP or continuous fiber reinforced plastics, and then even putting some of those carbon fiber type materials into the structural area, like the frame. So you can see that Toyota's done a lot of thinking about how to get more and more mass out of the body by tailoring the use of materials in their body structure. Now, when you put these different materials into an assembly like a body in white or body structure, you've got a lot of issues with joining. How do you join different materials, and even some of the materials themselves, how do they join to each other, as is the case with aluminum? Now, I'm not going to go through this, but I just wanted to point out that depending on what you're joining together here, there's different techniques that can be used, riveting, welding, adhesives, and so forth, that are basically the preferred way to join these different materials. So the point here is that as we go in the automotive industry from pretty much all mild steels to complex structures using all of these different kinds of materials, our design people are going to need to be able to work with the different these different joining technologies to make sure you don't get into trouble with the overall vehicle assembly. One last point I wanted to make here is that another factor that's very important in material selection, actually, is the importance of computer-aided engineering in developing body structures and vehicle structures. So much work is now done in computers before you even get to building hardware for testing and validation that you have to be able to have models that are accurate and that you have confidence in. But the trouble is, the more different materials you use, the more difficult it becomes with these complex joining techniques and all these different materials other than steel to have confidence and to be able to do a good job of simulating and analyzing these structures. So that's actually a consideration as the auto industry moves to different materials, is to make sure that they can still maintain accurate computer models of the strength and stiffness of the structure. So what are the skills then what we see and that we're learning as we talk to industry are going to be required in the field of lightweight vehicles? Well, we're talking here about designers and technicians. Our focus at CAAT has been on technicians through the first 3 to 4 years, but now we're expanding to include designers because designers are the ones that are going to be also very important in this era of lightweight vehicles. They need to be able to understand automotive materials properties for design, including strength, stiffness, formability, joining methods, repairability, recycling, all of these performance factors. They need to know how to work with proven sustainable automotive material choices, just as I pointed out earlier that engines are now pretty much all cast aluminum. Well, in the future, probably a lot more panels, a lot more components are going to be of a non-historic or non-traditional materials. They're going to need to be familiar with that. And then finally, they're going to have to understand systems engineering, or how these things go together, and how their selections on materials are going to affect CAE modeling and the manufacturing systems. So there's a lot of impact on designers as we go to some more sophisticated lightweight materials. Technicians are also going to be affected They're going to need the knowledge of how and when to repair many different automotive materials, the ability to assess and repair many different types of automotive joints and complex assemblies. And then they need to be familiar with how to identify and sort these materials for reprocessing. So the impact of this lightweighting technology is going to be large on both designers and technicians. And the biggest proof of this is the new Ford 2015 all-aluminum F-150 pickup truck. This is one of the largest selling models in the world, and Ford is betting on an all-aluminum body structure and closures for this vehicle. It's a huge commitment on their part to lightweighting technology, and this vehicle is going to be introduced later this year, and it's going to have impact on the service industry and the raw material suppliers and but it's going to be putting this technology in the hands of many people out in the consumer space. Okay, now we're going to talk finally here about automated and connected vehicles. And what are they? Well, you hear the term automated, autonomous, connected, and so forth. This is a graphic showing you that an automated vehicle, an autonomous automated vehicle, operates in isolation from other vehicles and just uses its internal sensors. It's not connected to other vehicles. It's not connected to the web or the satellite. A connected vehicle communicates with nearby vehicles and perhaps the infrastructure around it. And then there's the automated connected vehicles, which leverages that information that's being collected by the autonomous vehicle and the connected vehicle and can take over control of the vehicle, either in a limited or a total way. This is a chart that GM has put together that shows its roadmap to automated driving. And of course, the first level is where it's passive information. The driver is getting information and alerts, but the vehicle is not really doing any control functions. Now we have a driver assist package that has some limited control in emergency situations. The Super Cruise concept is coming, and I'll talk about that in a minute. And then there's sort of complex on-demand automation that's coming down the road, ultimately conceptually leading to totally chauffeured autonomous driving. The National Highway Traffic and Safety Administration has formally defined 5 different levels, levels 0 through 4, of this progression from no automation to full self-driving. And what are the technologies that are involved with getting to these high levels of automated vehicle? And this is one way of looking at it. If you look at the vehicle itself to the left, it could have radar, it could have cameras or image sensors, it could have sonar, then there's heads-up displays and the displays in the cockpit system. Then that type of vehicle could start going V2X, which means voice to V, voice to P, which is voice to pedestrian, voice to M, motorcycle. That's kind of what the X stands for. So if there's a signaling unit on another car or on the pedestrian's phone or around a motorcycle, that conceivably could be communicating with the vehicle and then providing information in terms of accident avoidance and so forth. Then there's the cloud, which everybody's familiar with now, right? We all know the cloud. And then finally the satellite system itself, the GPS system, which can provide valuable supplementary system information to the vehicle. So all of those sources of information then need to be integrated on the vehicle into an automated system. The vehicle needs to sense what's going on around it. Gets information from maps and GPS. I described the voice to the vehicle and vehicle to actually V2I is vehicle to infrastructure, which is another way to connect, for vehicles to connect. And taking all of this information together, then integrating it into telling the vehicle what to do. So this is a very, very complex engineering situation. And this is a one way of just delineating what some of these complexities are of automated driving. You've got the surround sensing of the vehicle itself, which we described. You've got the issues of data security, which if somebody could hack the vehicle or hack the information that's coming from the cloud, so there's security concerns. There's the system architecture itself, putting all this information together. There's keeping the map data current. And then there's a lot of issues in terms of the standards to make sure that everything can talk with each other in a standard way. And there's also, of course, the liability issues. If there should be an accident when a vehicle is being driven by itself, who's responsible? Is it the driver? Is it the company? So there's a lot of legal issues also involved with either partial or full vehicle automation. So what kind of knowledge does a worker now that's going to work in these areas need to have? Need to have working knowledge of wired and wireless protocols for these vehicle-to-vehicle and vehicle-to-infrastructure communications, networking knowledge, be able to configure and operate all of these switches, routers, firewalls, and security systems. Need to have fluency in the software that's going to be required to run all these systems, and you need to be able to conduct the kinds of testing for these systems and make sure that they all work within the automotive space. So there's, as you can see here, there's going to be skills required in the automotive industry of the future that have not been required in the past. So that's maybe there's maybe somebody has some questions at this point, perhaps Mike, or then we could continue on with our next poll.
You know, we've got a question break slide coming up. Isn't it coming up right after the poll here? Let me just advance this, Doug, because I think we want to pause there. Oh, I'm sorry. I'll tell you what, let's do this poll, and then we'll take a pause for a question break, okay?
Yeah.
So folks, thank you as we did that. People have already started responding. When do you think fully autonomous, the ones you've been talking about, Doug, going to be introduced? Is it going to be next year? No, that's not even an answer. 2020, 2025, 2030, or never? There's a good one. A lot of people responding quickly here. Let's just give them another moment and see what they think, and then we'll show the results of the poll. All right, here we go, folks. Let's do a quick countdown as soon as the operator figures out how to turn on the polling function. There we go. 5, 4, 3, 2, 1. Most people think 2030. Some say never. Quite a few say never. What do you think? And you want to talk about that for the question break?
Sure.
Okay, good. Let's take a pause while we ponder the answer to this question here, this polling question. Doug, we've got a ton of questions in the chat window. We won't have time to do all of them, but let me give you a sampling of some of them. And let's just start with the most recent one. You talked about V2X, or yeah, that's coming up, these various X's. Do you think insurance companies are going to respond with lower premiums for people that have those? I know it's sort of your opinion question.
Well, the number one objective of having automated vehicles is safety. You know,
reducing accidents.
Yeah, reducing accidents. So there should be, once it all shakes out, there should be actually lower insurance rates, and that's what the expectations are, because there should be greatly improved safety.
If you look at way back,
Bob, you agree with Doug there? Bob, excuse me.
Yes, I do. And auto insurance did get some adjustments back when ABS brakes were first introduced.
Oh yeah.
A lot of companies would give you a discount on your insurance if you had ABS brakes. And ABS brakes, to me, are really the first automated system that went into vehicles. And now there's been, more and more coming. But I think you probably will ultimately see insurance adjustments downward because of the technology making less accidents.
Okay, good comments there. Thank you. One of our attendees wondered if they should get that new aluminum F-150 or go for the Corvette. Some of us thought the Vet might be a bit more fun. So,
yeah. Do you want a sports car, or do you need a truck for getting work done?
Let's talk about a little bit about questions about those lightweight materials. Here's a great, a very insightful question in the chat box. Okay, these things are cool, but they could be tough when it gets to the repair side, right? These advanced materials, especially as corrosion influences those. I mean, it's not a conventional rust situation, right? It's quite a different sort of thing. Just give me a brief answer there. What do you think on the repair side of these type of materials?
Well, yeah, if you go back, you can go back and look at that one chart I showed on joining, recommended joining methods, and of course, just joining dissimilar metals, for example, is where you can get into a lot of corrosion trouble. Yeah. And there's been a lot of thought that's gone into how you do that. And so, yeah, that could be a potential corrosion's a potential issue. But most of these materials are inherently better for corrosion than mild steel.
Both aluminum and carbon fiber could be much better for corrosion, but you have to be very careful when you're putting aluminum and steel together. But that's already well understood, and most people understand what kinds of barriers you need to put in place so you don't get the corrosion between the two.
I guess that's the key, isn't it? The barrier is eliminated in the first place. I guess ultimately the repair guys are going to have to face it somehow.
The repair guys have a big challenge, though. I mean, how you repair aluminum, how you repair carbon fiber is drastically different than what we've done with steel for years. It's a whole new area.
Yeah. Go ahead. You go ahead.
And that's one that could actually have an upward effect on insurance cost.
I think we'll have more time towards the end. We're pretty good on time. We got to keep our pace moving. I'd say we're pretty darn close to the timing, but let me throw one more at you as long we're thinking about this. You talked about things like, the technicians now ought to have a working knowledge of wired and wireless communications. They ought to understand firewalls, and now they have to understand joining of dissimilar materials and then repairing them. Holy cow, the curriculum of a 2-year program has now become 4 years. What are we going to do here? Are we going to have subspecialties? What do you think?
I think so, just like in the medical field. You go to school and you learn the basics, but then you end up specializing in different areas. You will probably see the same thing happen here. In fact, there's already some of that within the auto industry as people go through particularly service programs. They get an overview, but then they have an opportunity to specialize in different areas. I think that will be probably an increasing trend.
Okay. Got a couple of technical questions about, again, back to repair these composites, but you know what? We're going to hold that question. Doug, I want you to continue. We've got some cool things coming up. Let's keep our pace moving. We're just about on time. Let's just keep moving here. So go ahead.
Okay. I just have a little bit more to go myself, and I'll pass it on to somebody else so that you can maintain your interest here. What I wanted to talk about next was one of the main things that we said was the objective here was to promote seed funding opportunities, because the CAAT Center for Advanced Automotive Technology, we have a bundle of money that we're trying to give away. Seed funding is part of what our grant provides, and it's funding that's available on a first-come, first-served basis for educational institutions to develop or adapt materials all the way from modules and artifacts to courses and complete curricula. We don't want to spend the money buying equipment, although we recognize that some equipment may need to be purchased on a limited basis. But we're looking to develop where there needs to be new curriculum. We would welcome proposals from institutions that were looking for money to help them update their materials and develop new materials for their curriculum. Now, in what areas are we looking? This is one way to look at it. If you look across the top, this is sort of the life cycle of a vehicle, all the way from pre-production where you're doing R&D and testing, to the production and manufacturing, to post-production where you're talking about service and reuse and recycling. And if you look down the left-hand side here, you're talking about some of the breakdowns of the vehicle systems, whether it's the entire system itself, energy storage, motors, controllers, and components, advanced engine systems, alternate fuel propulsion systems, and then we've added, of course, the lightweighting and materials and the connected and automated vehicles. And we've kind of laid out here where we think there might be a primary focus for the development and dissemination of curriculum in these different areas. So there's a number of opportunities that we envision that we could provide help. So the way it works is you submit a funding request and we provide the proposal template online, and then your proposal then comes to us and we review it and then approve it if it's something that fits both our scope and it's a well documented proposal that services what you're trying to do at your institution. And then we would provide payment on a contract basis. This is not a sub-grant. This is a contract, so we can kind of keep things simplified. And we provide funding as you go along in terms of the deliverables, the payments, and the reports, and so forth would be included in your proposal. So these are this is a listing that I'm not going to go through, of course, of the projects that we have funded to date. And we are fortunate to have two of the people here, both Charlie Standridge and Shannon Williams, to talk about their projects, so you can get an idea for how you might be able to how these funds have been used, and maybe get some ideas on how you could perhaps take advantage of them at your institution. So, Charlie.
Thank you for the introduction. I hope everybody can hear me. My phone dropped the call for a second there, and I just came back. So
we've got you, Charlie. You're good, Charlie. Go ahead.
Okay, thank you. I'm at Grand Valley State University, which is one of the 15 public institutions. We're located in Grand Rapids, Michigan. The School of Engineering is. Just to give you an idea where we're at, and we're also a very focused on application work. The focus of the university is on educating students as opposed to research. We're out in the community looking for ways to make things better within our College of Engineering and Computing. We do a lot of partnering projects with the local industry. And for this project, we're looking for partnerships with Muskegon Community College. We also already have a relationship there. Grand Valley offers some classes on site at Muskegon Community College, and we had a site representative there who was able to make some introductions. And so when we saw the opportunity at CAAT, we thought this was a good way to extend our partnership by working closely with the folks at Muskegon Community College who are also working in an area of interest to us, which was what do you do with the lithium-ion batteries when they come to the end of application life in a vehicle such as a car or an electric bus. And we've had some other funding in that regard to do some technical work, but we hadn't done what we like to do well, which is capture that knowledge for educating our students, and therefore we thought there was a good match with the CAAT Center in that regard. And I think there really is, because even if you look at the proposal process, it's very straightforward. To me, it's no more involved than writing a project plan that you would have to write anyway if you were going to conduct a project to work with some other folks in any regard at all. And I will say the folks there are very easy and straightforward to work with, which I really appreciate. Lindsay Carneal is sitting next to me. She's a professor in engineering that's doing some technical work with us on how do you recycle the cells of the lithium-ion batteries that you see there that came out of an electric bus and are no longer suitable for any use. On the left we see a photo of a workstation support activity, a box that contains the lithium-ion batteries during testing to make sure in case something goes wrong, what goes wrong doesn't get all over the place, which wouldn't be very good. So in the partnership with Muskegon Community College, they were looking at, their faculty were looking at the curriculum development and technical course assessment, and we were at Grand Valley able to provide some things that community college didn't have, like a graduate student. And we're able to support with doing some coordination of the grant activities, all the overhead functions. And also we're able to, as we'll see in a minute, integrate some of these activities, the modules that were developed, into our general education program. We took an approach of developing modules rather than a course because we wanted the materials to be reusable in a variety of contexts that may adapt over time. That is, courses can change, so we knew this material could be used in many places, and trying to get a new course into the curriculum sometimes is a hard thing to do. At least it would be with all the stuff we've got going on. So the modules we put together gave some overview, context, and perspective on how one might handle post-vehicle application lithium-ion batteries, including electrical topics, mechanical, chemical topics, and how do you handle them safely. You can see an illustration of what happens when something goes wrong sitting on the table in my office. Fortunately, it happened on a bus due to a leakage in containers, and there was a little kaboom there. Somewhat happens the same way that an M80 might explode if you ever shot off fireworks as a kid and your mother told you not to hold them in your hand while you were doing that. Also, we developed not only materials but active learning exercises because most of us had taught find out very quick that students are better at learning by doing than learning by listening to us, no matter how fantastic we think we are as lecturers and presenters. As I said, the proposal is short and straightforward. It's basically what you'd have to do to organize a project anyway, written down, and very easy to work with folks at Tacoma and doing proper revisions and getting everything lined up. And reporting follows a proposal outline. Again, it's good statements about what you were doing for good documentation in the first place. So everything had very minimal extra work or overhead to do, we found. And our results were at Muskegon Community College did this grant-supported partial development of a new course in lithium-ion battery chemistry, the science sequence. There's already a course in introducing hybrids and alternative fuel vehicles that the materials augmented and helped to grow. And at our place, we have in the junior and senior year requirements for all students to take courses in what they call global issues or big issues of the world, and we do have a course in there that we hope to offer in the near future on renewable energy systems that some of the materials in here will talk about energy storage using post-vehicle application batteries. And again, it helps strengthen our relationships at Muskegon Community College. And in the future, we're still working at with Northwestern Michigan Community College in Traverse City to build on what was done previously in some of their coursework on alternative vehicles and talking about how we could build additional modules and go back to the CAAT Center for funding on the hybrid electric for their hybrid electric vehicle class following the model we developed in Muskegon. I think that's the end of my time then. And so at this point, I'd like to pass the further discussion on to Sherry Doherty. Sherry?
No, Shannon.
On to Shannon. I'm sorry, I got my sequencing.
That's okay. Good afternoon. My name is Shannon Williams. I'm with Utica Community Schools. We also were awarded seed funding, and I will second what Charlie said about the process. It was very easy, very straightforward, easy to work with. So just to give you some context to where we applied our seed funding, we were in the process of, we had a lot of high school programs that were CTE, but what we were finding is we weren't having really tie-ins at the junior high level. As far as, you know, servicing our CTE programs or really guiding the students with what they needed. So we took a close look starting in 2012 at what was happening in the middle school level, and I think I cornered Doug at a conference one time and I said, the seed funding, does it go all the way down to middle school? And he said, well, let's talk about it. So we did. We started in Utica schools first with Exploratory Design and Engineering 1. Now this is not part of the seed funding. This is something that we needed to do with existing curriculum and kind of modify it so it took more of a project-based learning, engineering, mechanical design, architecture approach. It basically combined the best of drafting, the best of technology, and made it more project-based learning. Now that was implemented in 2013-14 school year, and the only reason that I'm bringing it up now is because it laid the groundwork for what we needed for the follow-up course, and that brought us to the seed funding. In 2013-14, the first year it ran, we had 795 students. This year is the second year it ran, we had 984 students sign up. So it's been very successful for us so far. Because of the positive feedback, the district came to me and said, well, what's next? What do we follow it up with? And we realized that one of the holes that we had is on the electronics, electric vehicle, that component. And then when I went to the conference, I thought this could be a great fit. So hence the proposal was written to create Exploratory Design and Engineering 2. Now we use seed funding for this. I will say that this curriculum is standalone. It does not, we use it as EDE1 as a prerequisite, but it's not written as such. That was just a need that we had as a district. Anyone else who wanted to come in and take this particular course or use some of the components would not need to rely on our EDE1 class to do it. So I'll just say that. We implemented it this year, and it's for 7th through 9th grade students. Right now we have 268 students enrolled, and they enrolled before the class was fully even written. So the excitement around it was there. I expect these numbers to increase after this first year. The course in a nutshell is Electronics 101. Then we get into different sources of power with different mini projects, and our capstone is to build an electric vehicle. This is just kind of the content expanded. With Electronics 101, we relied a lot on the Cheney kits. They're fantastic, but I am blessed with a fantastic development team. One of my instructors is also from industry, an electrical engineer, so he was able to take some of the existing material and really put support material in it for a junior high student, everything down from schematics to just, you know, easier documents for them to follow along with. So that's all part of the curriculum. So once they get Electronics 101, this is really when we get into the project-based learning of it. We look at everything we're using magnets, battery power, voltage, solar power. You'll see a few pictures of some of the projects that we did. I have a junior high student in my house, so I made him test all the projects, so they are tested by the junior high population. It's very project-based learning. And then the last component is our electric vehicle, where the students then take and design an electric vehicle. They have to do trade show type approach with it, where they have to market it. They have to just, you know, defend why they made the choices. When we developed this course, we were very mindful on the engineering practices for Next Gen. I know Next Gen science standards are still in the process of being fully adopted, but we were trying to look at everything from Common Core, all the different standards, and really take a holistic approach to the curriculum as far as how the students learn and what they learn at the same time. So with the trade show, they have to have the communication piece, a lot of documentation that goes into that. All that curriculum was written using the seed funding. The students would then race, and then they would have to come back. They evaluate. They have to retool because their first race was for speed. Their second race was for distance. So then they have to determine what modifications that they would have to make to adjust to the new standards for what their goal is. And then they would end up doing more of like a tractor pull type of approach where they have to then pull weight. So then they'd race again. The development process, like I said, was very easy to work with CAAT for the seed funding. We first met in December. I believe that's when it kind of kicked off. We wrote the grant and the proposal. We received word that we received the funding in February, and that's when we kind of dove in on our end. Throughout February and April, that's when my curriculum team kind of put it together. Those are the people involved. On April 15th, we ran a professional development for the teachers who could potentially teach the class. We were still developing the curriculum at that time, though, so we didn't roll it out then, but we wanted to create some excitement. We had everyone from Workforce Intelligence Network, an engineer at Chrysler, CAAT was there, Wayne State University came. We had someone from the MISD talk about project-based learning, so it really is just kind of getting the teachers on board and excited. In May for the IVD competition, some of those teachers then were invited back to go to that to see the excitement around electric vehicle design. And then in June, we finished it off with a 2-day summer workshop. Those are pictures on the right are some of the teachers and the actual workshop we had where we brought in all the material. The teachers got to play with it. We got to walk them through the curriculum, and it was very well received. So in closing, this was our course. It really takes a look at, electronics and electricity, different sources of power, with really bringing it into the electric vehicle at the end. It's written for a junior high student. It's written in a way that we try to look at all the different soft skills that are known to be missing in some of the candidates for jobs out there, like the ones listed on the right. So overall, it was a great process. We would definitely do it again, and thank you for listening. And I believe, this next slide, just really quick. This, if you ever do, all these resources are going to be on the CAAT website, but this is kind of what you would see if you went to ours, where you would see here's the battery unit when we talk about the battery mini project, and we literally broke it out into different assessments, worksheets, what we would do on each day, and then this is the Electronics 101, so that's all in there, and then a curriculum at a glance was all created. And now, Sherry is up, and she's going to do the website.
Can we put in one plug here for a minute, though, on seed funding? For those of you that are out there listening, if you have something going on in automated vehicles and lightweighting, those are the areas we're expanding into, and we would love to have you submit some proposals to us to do some curriculum development in that area. There was a question about research-focused proposal. We have not really done anything that's been research-focused at this point. It's all been more application, particularly looking for curriculum development that other people then can take and use, because we put all of this on our website so it is available for other people to use. Sherry.
Okay, thank you, Bob. I'm going to spend just a few minutes now sharing with you some of the key elements of our website. If you haven't had a chance to visit our website yet, you can see we have the address up there at autocat.org. What you're looking at here is our home page, and across the blue bar at the top there you see the key areas of our website. So we have information about the CAAT, we have information for educators, industry, students, and then some of our resources, and we'll talk more about those in just a minute. In the lower half of our webpage, you'll see on the left side there we have an area for industry-related news and events, and we update those nearly daily. And then the right side of that lower level is some of the activities that we have coming up, and we'll share a little bit more with you about those as well. As you can see on this chart, our growth on our website since we launched in late 2012 has been pretty good. We had more than 3,000 visits to our website in 2013 and more than 2,200 users. And in just the first 8 months of 2014, we've already doubled and tripled those numbers, and of course we expect that to go higher by the end of the year. We launched our social media with Facebook, LinkedIn, and Twitter in December of 2013, and so far this year we're up to about 300 followers in our social media. We're pleased with our progress so far, and hope that we see that continue to grow. On our About Us page, you can learn a little bit more about what the CAAT's about. You can check out the staff that we have here. We have a page on our conference. Right now, if you look at that conference page, you'll see that we have a save the date for the 2015 event. And then below that, we have information on the 2014 conference. That's where you can find the links to the content from last year's conference if you're interested in some of what Doug told you about earlier. We also have a photo gallery of some of our events, and then down at the bottom you see we've got our brochures available for download, and we've got a flyer as well, so you can check those out. On our educator page, as you heard from both Shannon and Charlie, the process for seed funding is pretty easy. That's because we have it all right here for you on our website. You can see all the little click here's. You can download the forms and find information. You can see the same chart that Doug showed you with all the projects we have. We have a page for that on the website as well. That's the funded programs page. We also have the professional development opportunities page for the educators here, and you can see some of the educational partners that we've partnered with. On our industry page, we provide you with a list of our Industry Advisory Council members, and we have an up page for the professional development opportunities for our industry people. What you see on the page here is the lightweighting seminar that we have coming up. You can check that out. As I mentioned, two of the events that we have coming up are our 2015 CAAT conference. Our conference is free. It's located here at McComb Community College in Warren, Michigan. It's scheduled for Friday, May 1st, 2015, and it does include a continental breakfast and lunch, so we hope you'll join us for that. And we have the lightweighting seminar open to both educators and industry. That's scheduled for October 15th. It's going to be at our center campus in Clinton Township. That's also free, and we're working with the ASB Foundation for that event. For students, we have a career pathways page that shows progression from our electric vehicle technology certificate through an applied science associate degree, then on to bachelor's degrees at Wayne State University, and then what potential jobs you could get at each stage. We have a page on the electric vehicle technology certificate program. We have a page indicating all of the electric vehicle and alternative fuel courses that are available in Michigan. And we also have a page for our student activities. I'm not going to go into detail here, but this shows you some of the student activities that we have done annually. There's more information on the web page about each of these events. Our resources page includes a page for our webinars, so you would have been able to register for today's webinar through this page. If you missed our first webinar, I want to go back and listen to that. The audio file and the presentation is available on that page. And we have a page for our newsletter. Again, you can sign up for our newsletter or view the archived versions of our newsletter. And we also have a charging station locator if you're interested in finding where the charging stations are near you. Our monthly newsletter, we encourage you to sign up for that. You can visit autocat.org. If you just click on the resources area, then on newsletter, you'll be brought to the page that you see on the right there. And then you can just click and we'll collect the information we need to get you added to our distribution list for the newsletter. We offer a free resource library. What you're looking at on the page here is a list of the resources that we have available. And we do break it down into various categories, the type of technology, education level, audience. If you're looking for something in particular, we can help steer you to the right items that we have available for you. And then the number off to the right is how many we have in each category. Keep in mind some of them are listed in multiple categories. We also encourage you to submit a resource, and you can do that in this area as well if you have something, some curriculum item or artifact that you'd like to share. We'd be happy to take a look at it, and if it is appropriate, we would post it in our library. Also included in our library, we have conference resources, and that includes materials from both our conferences and conferences that we have attended and collected items from those conferences. So all of that is available to you for free in our free resource library. We have a technology section, and off to the left there you see all of the technologies that we have available. What I have up is the automated and connected vehicles page. We added this just recently. We also have the materials lightweighting page, so we have information about those technologies. And we recently added a lot of videos to this section that help demonstrate the technologies. And how can you stay connected with us? Well, we do encourage you to visit our website. Again, it's autocat.org. Sign up for our monthly newsletter. follow us on our social media if you prefer that route. Plan to attend our conference on May 1st next year. Last but not least, we do encourage you to contact us with your seed funding project ideas. We do want to hear from you. I think that's all I have. Brings us to the end of our presentation.
Thank you, Sherry. You know, I think we've got a bunch of questions here, but what I'd like to do, folks, is just do a brief survey. That helps us pay the bills. I say that tongue-in-cheek, but it helps us respond to the National Science Foundation, our sponsor, about the value of these webinars. Just been great today, a ton of interest in the chat window. Let me launch the survey. Let's see if I can figure out how to do that here. And then while that survey is up and people are responding to it, I'll have an opportunity to ask you the final questions. Okay, hold on, folks, just a second. The survey will appear on your screen, provided I do it correctly, and you can click on the radio buttons and so on. Here we go. And there it is. Okay, so the survey is up on the screen. Presenters, please don't touch the survey. That'll could accidentally turn it off. Sherry, there's a question for you right at the end, and it says, what is the deadline? What's the deadline coming up for these seed funding? Everyone's interested in the seed funding, the next round.
We don't have a particular deadline. We just have a pot of money that we're trying to spend before the grant runs out. So I would encourage you to get your ideas put together. Of course, the sooner the better. But there's no one deadline.
Well, the only timing deadline is our grant ends July 31st, 2017. Okay. So your project or whatever would need to be done by then, with all invoices submitted. But hopefully it will be more an issue of we run out of money first before we run out of time.
So folks online, I just wanted you to note that we've heard that they have pots of money and bundles of money so far. So I'm going to be putting together my proposal, I tell you. No, I think it's a great opportunity. I like that list of things that you've done because, you know why? The people who are doing those seed projects, they're really right on the ground and developing what's appropriate and then sharing it with others. I think that's a very cool thing. Let me ask you another question. This one's a bit more philosophical. We talked a lot about how the skill requirements are going up. We need IT skills, we need barriers between dissimilar metal, repair skills, but have the salaries, have the wages kept pace? Can we continue to attract students to these now more demanding positions? What's your take on that? Bob, do you want to start, and then we might ask Doug what he thinks.
Well, yeah. In fact, I just heard a commentary on that on the radio on the way in today, that there's a tremendous amount of hiring that's going on, and that employers are going to have to be paying wages that are attractive if they really want to attract the right talent. So I think there's going to be that sort of pressure that will be there, and people that have the right skills will be able to demand a reasonable wage for that. And the skills that are needed, we have an industry advisory council, and we said, what you're looking for today from a technician is someone that knows how to do mechanical, electrical, and software. It's a combination of those three. And if you look at the automated vehicle space, that is particularly true. So it's really a multifaceted skill that these people need to have. And it's not something you will have with just a high school education.
I just add a couple more comments to that. When we talk to industry, there's a lot of potential for people that come in at entry level with these kind of skills to also grow within the company. It's substantial. And the other thing that's happening is that there's getting to be a concentration of these high-tech areas, certainly here in southeastern Michigan and even in western Michigan, and perhaps some other areas of the country too, in some areas of California and so forth. So there's a lot of job potential out there. And as Bob says, there's going to perhaps even be competition once, because the forecast for the industry is pretty solid. It's not like we're the work is going to be going overseas for these things, because it's actually coming more into the region than it is moving out of the region in recent years, particularly product development kind of work. So those are a couple of the other positive aspects of it. There's no question that there's been some loss of salary levels within the auto industry, but not necessarily so much in this product development space, more in the manufacturing space.
Right. Within manufacturing, there is now what's known as a two-tier wage structure within manufacturing, but that really has not occurred in more of the technical support areas. And within the technical support, there's a need for people that have these hands-on skills. We're not looking at just engineers. We're looking at, technicians. There's people that are needed to do this work, and they can be some very well-paying positions.
Excellent comments there. The industry certainly is changing. That was clear from your presentation today. One of our questions that came up earlier, I'll just refer back to that. You showed a graph that talked about demand and salaries and positions. One of the questions that came up, I don't know if you remember that one, were you referring there, I'm sorry to drive us back to that earlier slide, to both salaried and non-salaried positions? Do you remember that particular slide the question came about? I can't remember what slide it was.
Well, we showed a chart on total. We showed a chart on total, employment levels. I don't think we should on salaries, and that does include.
It does include both.
All employees, yes.
Okay, total. Right, good. Just a small clarification there because people were interested in that. One last question here, and boy, our time is just so perfect. We've used the term light weighting and light vehicle, and this is a question. You showed a graph of light vehicle sales. I don't think that means light weighting, doesn't it? What is a light vehicle when you talk about sales of light vehicles?
Yeah, a light sale usually means automobiles or cars and light trucks together. Not medium and heavy trucks. Yeah.
Right. Okay, that's clear. We weren't sure about that, but it was an interesting graph. A couple of questions about that.
Yeah.
All right, very good. Folks, we're now, oh man, we are so perfectly on time. It's just great. I encourage you participants, please, to finish off clicking on your circle boxes there. We're almost done for today. We did have an opportunity for you to type in some suggestions for future CAAT webinars, any additional comments you want. And also, if you're willing, type in your name there because, again, we might want to follow back with you to see how these webinars impact your classroom practices. We do that to try to continuously improve what we're doing. So presenters, while we're clicking our last little buttons here, I wanted to thank you for just a great, very engaging presentation today. Charlie, appreciate your logging in and calling in, talking about your seed funding results. Very interesting for what you guys achieved there. Then also Shannon, we loved hearing about your widespread test with middle 15-year-old students. How many of those students were involved in the testing of your materials? That was just great to hear those extensive results there. But it was fun, and I think we could see that sort of activity would be appealing to students. Thank you. So, all right, everyone, I'm going to close the polling device. How do I do that? Oh, I remember. Here we go. Polls are closing in 5 seconds. 5, 4, 3, 2, 1. Okay, polls are closed. Thank you very much. We just did our final questions. Again, it was just great to be with everyone today. This officially ends our webinar. There will be recording links and a link to the PowerPoint presentation sent to all presenters. Bob and Doug and Sherry, if you'd stay on the line for a few minutes after I close our teleconference, we can debrief. Thank you, everyone. Goodbye.